Your code can be separated into two different parts: indeterministic code and deterministic code. Deterministic code executes the exact same way every single time you execute it, regardless of its environment. Indeterministic code executes differently every single time. Why? Because it depends upon its environment, its state, etc. The reasons why indeterministic code executes differently is because it is dependent upon I/O. I/O meaning disk, database, or network information. As an enterprise software developer, 98% of your code is indeterministic. If you look through your code, you will realize that 98% of its parts are either reading data from a database, or it's fetching data over its network card, maybe an HTTP invocation, or it is reading data from disk file system. Testing indeterministic code is useless. It serves absolutely no purpose whatsoever. And then we have these best practices that tells us that unless our code has a coverage of at least 80%, then we are violating our industry's best practices. But when you are testing indeterministic code, you are forced into using mock objects and or testing over I/O. And testing over I/O is an anti-design pattern. Now, if you are using mock objects, the only thing you achieve is to test your mock object configuration. If you're testing over I/O, implying database, or network, or disk, then you need to ensure that every single time the unit tests are executing, you have the same state resulting in the same responses from these I/O invocations. Unit testing as a software developer in the enterprise space is basically useless, because everything we do almost is indeterministic code. Now, with that in mind, let me show you how I test my code, my client code, the code I'm creating for my clients. Let's say I need to create an HTTP endpoint, and I want the endpoint to execute some SQL, implying it's indeterministic code. So the first thing I would do, I would go to create, I would go to SQL Studio, I would choose SQL View, and I would start writing my code, right? And at this point, I get to play with my SQL. Let me load up, let me change to my actual cloudlet here, my demo cloudlet instead. Let me go into create, let me go into SQL Studio, where I have this Chinook database that I spoke about in my previous video, and just find a snippet. Okay, let's do artist album, right? So here I have a snippet of SQL that basically joins from artist to album. So it lists all albums that belongs to every single artist in the system. Now, here I can play with my SQL, right? In a join where al.title like f, right? So now it's only returning albums whose title contains F. So now when I'm done with my SQL and I'm happy with the way it performs, I can copy this SQL, can go into endpoint generator, I can choose SQL endpoint generator, choose my Chinook database, and I just paste in the SQL. And now I can dynamically exchange this guy with @filter and then reference an actual argument whose name is filter inside of my SQL here. So this becomes an SQL parameter. Then I can choose my method, get, and I can choose generate endpoint. Now, if I open up manage and endpoints in a different tab here now, and I filter for Chinook and I have a look at this endpoint, here, then I can test it. If I now add AC, then it's returning only albums belonging to company or albums having a title containing the two characters consecutively AC. Now, now I can test my code. And I can test it immediately after having created it. And if I want to later edit the code, I can open up Hyper IDE here in a different browser window. I can expand my Chinook here, and I can filter for custom SQL, and I can edit the code here. When I'm done editing the code, let's say I want to let's say I want it to be a publicly available HTTP endpoint, so I can just remove the auth.ticket.verify, save the guy, demaximize, click function F5, and then I can add FA. I don't know if that's going to return in the album. Yeah, okay, facelift it did. So I have now perfectly tested my code. There's absolutely nothing I can achieve by adding unit testing to this thing. It's adding a unit test to this code is just pointless.
However, if I add unit tests to what I just did now, I need to create a CI/CD pipeline that executes upon commits towards its upstream Git repository. I need to add complexity to the project as a whole that significantly decreases my velocity. I need to add a unit test project that somehow executes my tests. I need to create and configure mock objects that I'm using inside of my test instead of the database connection. At which point really what I'm testing is my mock object configurations. I'm not really testing my code, right? I mean, 90% of that code was SQL. So what am I accomplishing by unit testing that code? Nothing, absolutely nothing. Now, 98% of your code, if you are an enterprise software developer such as I am, or used to be for 25 years, then 98% of your code is code like that. Code that executes at the end of the line some snippet of SQL, or reads a file from disk, or invokes an HTTP connection or invocation or something, fetches data from the network, etc., etc. However, we keep on adding tests to that code because we are taught that unless we have 80% coverage, we're like doing something wrong. Oh my God, we're doing something wrong, right? And industry best practices dictates that unless you're unit testing, you're like somehow a malicious, vicious, arrogant, ignorant guy when it's just rubbish. You don't need to unit test code like that. You need to test it, right? But you don't need unit tests. And if you watched carefully at what I did inside of SQL Studio and the SQL endpoint generator, you would realize that my code is 100% perfectly quality assured by me manually executing the SQL and testing the endpoint. There is absolutely nothing I would achieve by adding automated unit tests on top of that code. Nothing.